If anybody else comes in or asks to come in, let me know. Somebody leaves their microphone on, or if somebody sees a message from somebody with a microphone, kind of holler it out, okay?
All right.
All right, today we're going to start with rates. And those of you that haven't had calculus in a while, just brushing up on this. We're not going to spend a lot of time on it. We're just going to work maybe 5 or 6 problems, or talk about 5 or 6 problems today, and then go into work. That's basically what we're going to do, and then we're going to have a test on this. Hopefully y'all are working on your test and homework from the last little unit, and this will be the second part of the unit, and hopefully we'll get unit 1 out of the way. So, what is a rate? Well, so far we've been studying, and in algebra and all the way up into calculus, we study just certain parts. And when I say certain parts, if I was to take you back to algebra, we always thought in terms of x and what? Y. In other words, if I give you a point, f of x is equal to x squared, then you plug in -2, -1, 0, 1, 2, then you get 4, 1, 0, 1, 4, and you draw a parabola. And that's your algebra. And then we came along and we told you to put a limit with your algebra, and then you had calculus. And then we told you that derivative is the tangent, and then we told you that the antiderivative was the area under the curve. Now we're telling you that with each x and each y, you have a rate that goes with both x and y. And the rate of x is dx dy, and the rate of, I'm sorry, dy dt, dx dt, I'm sorry, I'm sorry, dt, and dy dt. Okay? In other words, if something is, in algebra, everything was what? Static. What does static mean? Huh? I'm sorry, what? It doesn't change. In other words, it's sitting what? Still. Like this ladder. This ladder right here is sitting still. So you're in algebra right now. And what did you learn in algebra? You learned that a squared plus b squared is equal to what? C squared, because you got a triangle. Now, apply the real world, which is algebra. I mean, not algebra. Calculus and physics, of course. Well, you can't have physics without calculus. You can't have calculus without physics. No. Physics is dependent upon calculus. So, now you've got something else. You've got a rate. In other words, as soon as that ladder really hold on. See when he pops in. Hold on. There he is. Sorry about that. Okay, Amir, Jakir, can you see me? Can you see my desktop?
Yeah, I'll sit down.
Okay. Alrighty. Now, let me get back to where I was. Okay. As soon as we apply motion to X and Y, we got to worry about dx and dy dt. Now, we are bringing in that dreaded variable of what? Time. Okay? So, really, what we're doing is we are dealing with not only two variables, but we're dealing with what? The third variable, which is time. So, if you have a ladder falling, the rate that X is moving out is directly related to the way that Y is dropping. Okay? Now, what in the world does that have to do with what we're doing? Well, that's it. You got to think out of the box. You can't think of your algebra days plotting points and drawing a line. You have to think in terms of three variables. And every time you're dealing with one of these rates of change, there's one step. One, you got to think of the base formula. And then two, you got to think of dx dt and dy dt. And in some cases, a third, dz dt. Now, in this problem, I've already given you the base formula. What is the base formula for this problem? Because it's a triangle. Anytime you see a triangle, your base formula is going to be a squared plus b squared. But when you have a circle, you still have the formula of radius and diameter and circumference and all that stuff, okay? So let's move on to another one, a boat winch. And I only got 20 minutes because they still have it. Evidently, it takes a while for them to buy a license. The problem is, I'm the only one on campus that uses this. If there was 10 of us using it, it'd get done faster. All right, so here is a boat winch. Now, all of these problems are what you're going to see in your homework and the test. So, again, you've got to look at the formula, and you've got to look and you see, reel it in. There it is. And of course, if you want to see, now in this case, it's dx dt that we're finding because the boat is moving in the x direction. Now, you could, let me go ahead and say, why wasn't you measuring in the y direction here? Well, why are we measuring in the y direction here? Well, if you're going to mess with a ladder, how are you going to mess with a ladder? On the ground. You're not going to sit up here, well, let me climb this wall and push this ladder down. Okay? You're going to mess with the ladder in the x direction, so what are you going to be measuring? You're going to be measuring how it's dropping. Because you're down here pushing it or pulling it. You're not going to sit up here and go, well, let me climb this wall and I'm going to push it down. That's not going to happen. Whereas with the boat, you're not going to get up here and measure in the y direction because the y direction is not going to change. In this case, you're going to be measuring dx dt. And there's dx dt. Now, again, it's very important that you understand that you're looking at the time with this. It's kind of like time is sitting out here, and you're dealing with x and y with your algebra days, but now you're bringing in time with the x and the y. Conical tank. Again, you're going to be dealing with a squared plus b squared is equal to c squared. And you're also going to be dealing with the radius of what? Of a circle, Hubert. Yeah, that's what I'm outlining right here. If y'all follow the little arrow that's outlining the circle. So in this case, a conical section, you're talking about also what is that radius doing as the tank fills up. So just think about your ladder being right here. You see what I'm saying? And if you're pushing the bottom of the ladder right here, what is your ladder doing against the wall? It's going up. It's very important that you see this stuff, and that's why I spend so much time on these visuals. If you don't see what you're bringing into the problem, you're never going to understand what you're doing in the problem. And if you put your ladder, let me take a handy dandy straight edge right here, and let's color it this color, and I guess just use this. Here is your ladder, and then your X is right here, and then your Y, of course, is the only place that's, there's your Y. So if you relate it back to the ladder, oh well, anyway, if you add it back to the ladder, you see that this place right here is right here. And here's your ladder. So if you don't understand the ladder problem, you're not going to understand the conic problem, or the conic tank. And of course, then you have the lamp post. That was my question that we did that semester. I may have told you, I don't know, but we did it that semester, and I got 84% retention rate, and other teachers got like 17%. Oh well, I can't show you anymore. I'm sorry. I wish I could show you more, but my 20 minutes is up. But we might get purchased by next semester, so you know. Huh? Yeah. Yeah, might get, but the company don't exist, so quit. I have to quit now. Huh? I don't know, but the whole point is, like I said, if there was 10 of us using it, we already had it. It's all in the minority. I meant majority, which that's the way it's supposed to be. I'm not going to fuss. But with the School of Technology, we're supposed to be, oh well, I'm not going to leave it alone. Okay, so now we can't see any more pictures, so we're going to have to start with work now. Sorry. And when you're talking about a ladder, you're talking about a squared plus b squared is equal to c squared. So let me find my ladder. I couldn't find my notebook. I have a notebook on all this stuff, so I'm going to have to find my notebook later. Let me find my ladder problem, because I like to have problems already done, because yeah. Oh, I got a ladder problem. Yeah. Here we go. So let's go with a 20-foot ladder. 20-foot ladder is pulled away at 5 feet per second. This ain't a problem, really. Oh. What is the change rate of change of area under the ladder? when the ladder is at 8 feet from the wall. Is 8 feet from the wall. Now, the first thing you want to do is draw a picture. Label everything. Of course, if you're in physics, you know you got to label everything. Free body diagram, label everything. Now, you're going to be working with two formulas here, because the question asks for two, well, the question asks for one thing, but you're going to have to use two formulas. You're going to be using a squared plus b squared is equal to c squared, and you're also going to be using what? The area of a what? The area of a triangle. So we know that the ladder is 20 foot. We know that 8 foot from the wall is right here. So we can go ahead and find at 8 foot what y is by using what? Pythagorean theorem. So then this is for later. So I'm just going to put for later. Ladder. Later. Later. 20 squared is equal to 8 squared plus x squared, or y squared. And 400 is equal to 64 plus y squared minus 64. Y squared is equal to, what's 400 minus 64? What's 400 minus 64? I'm sorry, what? 336, and then take the square root of that. What's that equal to? 18.3. Now, we may or may not need that, but the main thing is we have it. Okay, so just leave that over to the side. Now, this is y. So that means dy dt is right with it. And this is x. X is equal to 8. And dx dt is equal to what? Well, dx dt is given in the problem. 5 feet per second. We also got area equals 1/2 base times the height. Because it's asking for the area. Okay, now, since we're dealing with area, we've got dA dt. And one thing that you need to remember about these work problems and related rate problems is every variable that you're given is going to be having a dt with it. And you've got to either plug and chug the dt number in, or you've got to find out what the dt number is. One of the two. Now, take the derivative in respect to dA dt, or in respect to t of this right here. Do that. Because that's what you're going to be doing. The first thing you're going to do, like I said, well, the first thing you're going to do is draw a picture. Second thing you're going to do is define the formulas that you're going to be using. Third thing you're going to do is you're going to set up the formula and set up the derivative. And then once you set up the derivative, then you'll start seeing what you have and what you don't have. So, using our implicit differentiation, we're going to get dA dt is equal to 1/2. And then what is the derivative of b in respect to time? That's going to be b times dB dt. Remember your implicit differentiation, whenever you, whenever you take the derivative of something, you have to take that thing, remember, y times y prime. You have to multiply it times y prime or whatever when you're taking the implicit differentiations. And then that's going to be plus h, or times, let's see, plus h, because you're using the product rule, h dh dt. Now we don't have a dH dt, so we're going to have to eliminate dH dt. So we're going to use the Pythagorean theorem to do that. So we got dA dt, and that's what we're looking for, is equal to 1/2 b dB. Now remember, your b is going to be your x, and this is your y. So we can call this b if you want to. Yeah, because first times the derivative of the second plus second times the derivative of the first. Power rule. Power rule. Okay. First times the derivative of the second plus the second times the derivative of the first comes out to be this. And this is b, and this is dB dt. And this is h.
Wait, Faith has a question.
Faith, oh gosh. No microphone, Faith. Hold on. And this would be dH dt. Here we go. Okay, hold on. Let's go back and see what Faith had a question about. What's your question, Faith? Okay. Call what B? Call, you just said call this B, and I want to be sure be sure what that was. Yeah, in other words, let me scrunch this down. Hold on. In other words, this is y, and this is x. And you can change this to be, or you can change this to dA dt is equal to 1/2, and then b would be x, and then this would be dx dt plus y dy dt. Okay, now we've not been given dy dt. We haven't got anything in there that's telling us what dy dt is. So we're going to have to put dy dt, or y, in respect to b. So how do you do that? Well, we go back to the Pythagorean theorem. And you just change this and say b squared plus h squared is equal to c squared. All right. If you want to solve for h, which we don't have a dH dt or a dy dt. We don't have that. We don't have the rate that this is changing. So we're going to solve for h. So h is equal to what? The square root of what? C squared minus what? B squared. And we're going to use that in the H spot, or the DHDT. Of course, you can plug in your 20, and that would be 400 minus B squared. So put that 20 in there, and that would be 400 minus B squared.
And then one more thing, on the DHDT, there's one that should the B plus H be in braces.
Where?
Bottom left.
Right here?
Yeah, should the B plus H terms be in braces. As well as be the both.
Yes. I'm sorry. Yes. I'm sorry. Because it's 1/2 times yes. Thank you. Okay, now you should have everything you need now to plug and chug. So take your, let me scrunch all this down. See if I can scrunch it down. Let's see. And of course, there we go. Group. Okay, hopefully everybody has that written down. Now, I'm going to take, so this is kind of like part one. Not part one, but the first part of setting up your program. Oh, well. Now, take A is equal 1/2 base times the height, and plug in this right here. So A is equal to 1/2 the base times 400, the square root of 400 minus B squared. And take the derivative of what's left. A is equal to 1/2, I'm going to put the 1/2 out front. Take the derivative of that. Of course, you're going to change it to the 1/2 power. So that's going to be B times 400 minus B squared to the 1/2 power. Now you're going to have to take it in, remember, dB dt. I would just quit. Too difficult. Too much stuff. Bring pencil down. Mr. Wizenhunt, is this coming back to you, knocking the cobwebs loose?
I don't remember going over this, honestly, in Calc 1. This is kind of new for me. So.
Yeah. A lot of people don't go over it in Calc 1. My students did. Any others seeing it for the first time on Skype? Okay. Anybody in here? Well, most of y'all
Except for you've seen this is the first time you've seen it. See how lucky y'all were to have me? All right, so that's going to be A. Well, you're going to have dA dt. Yeah. dA dt, you want to make sure. Yeah. dA dt is equal to 1/2, and then we're going to take first times the derivative of the second. Well, that's going to be 1/2 times, what's the derivative of, well, this would be the chain rule, so that'd be 400 minus b squared to the what? Negative 1/2. And then what's the derivative of what's inside? Be negative 2b. And then that's going to be what? dB dt. First times the derivative of the second plus the second times the derivative of the first. Plus the second, which would be 400 minus b squared. 400 minus b squared to the 1/2 times the derivative of the first, which would be 1 dB dt. Times the derivative of the first, which would be dB dt. Now, if you notice, what do we have from the original problem? What do we have? We have dB dt, and we also have what? B, Hubert. That's right, class. And what is this in terms of? B. So, what should you do? Plug and chug. Well, you can simplify if you want to. Simplify as much as you can. Looks like that 1/2 will take out that 2. However you want to do it. dA dt is equal to 1/2, and I'm just going to plug in the stuff. 8, we don't have to, times 1/2, 400 minus 64 to the negative 1/2 times negative 2 times 8. dB dt is 5. And so on. I'm just going to and when you do all the math, I got 37 feet. I mean 37. I'm gonna just leave it at 37 feet squared per second. 37 ... square feet per second. Now, right now, there's 2 or 3 people in the classroom. There's one person going, oh yeah, I had an exceptional teacher in Calc 1. I remember this. And then there's the other type that are going, I remember this a little bit, but we didn't spend much time on it. And then there's a student that's going, I've seen this for the first time, I'm a little bit worried. Okay? Well, for that last student that's saying I'm a little bit worried, after about the 3rd or 4th problem, you'll start to see the pattern. You'll start to see the pattern of finding the formula to work with, take the derivative in respect to t, and then start figuring out how to plug and chug to find the answer. And it'll fall into place after about 3, 4, 5 problems, depends on the person. You'll start to see how to do it. Okay? And you can ask my Calc 1 students. After about the 100th problem, they started to see it. But I really did not want to start with that problem. I really wanted to start with just the ladder problem. That's what I'm trying to find. Let me pull the one out of the book. Let me find this. Let me pull one out of the book, because the ladder problem is the best problem to start with, not this one. But that's why I was kind of aggravated when I saw that it was the area. Let me pull, I think it's example 2. There it is. Let me snip it. Like I said, I have all these problems in a notebook and I can't find my notebook. Damn Russians. Whenever something goes wrong now, you just blame the Russians. You don't blame Bush. You just blame the Russians. Used to be Bush, but now it's the Russians. That's not what I want. Go away. I'm going to blow this up because it's not too clear. There we go. Alright, snip. Snip that. All right, write that one down, draw it out. And of course, we're going to be working with the Pythagorean theorem. And that's why I wanted to show this one first, because this one is just straightforward Pythagorean theorem. Also, when you get through writing the problem down, write out what you have. Do you have x? Do you have y? Do you have dx dt? Do you have dy dt? What do you have? Okay, the bottom of the ladder slides away from the wall at a rate of 1 foot per second. So we have dx what? dt is equal to 1 foot per second. And which way is it going? Slides away. So that means the ladder is going to be going what? Down. So that means you're probably going to get a negative dy dx. I mean, yeah, we won't dt, sorry. We also have, later on, when the bottom of the ladder is 6 feet from the wall. So that's what's given to us. So
Let me ask you a question. When you were in algebra, if you were given x, what are you supposed to find? Y. If you're given y, what are you supposed to find? What are you given here? Dx dt. So what are you going to find? Dy dt. So you've got to take your formula, whatever formula you're going to use here, which is what? Take the derivative and find and solve for dy dt. And once you have dy dt, then you can start plugging in the numbers. You've got to think, you got to not think of algebra, but at the same time think of algebra, but think outside the box. Now we're not plugging in for y and x. We're plugging in for dy and dx, dy dt and dx dt. So if you're given dx dt, then you've got to find a formula for dy dt so you can plug in dx dt. Does that make sense? Just like you were doing back in algebra. So, x squared plus y squared is equal to z squared. There's your Pythagorean theorem. All right? Now, the only way to get dy dx out of that is to take the what? Take the derivative. But what about z? Well, you've got z. What is z? 10, right? So that's equal to 100. Now take the derivative in respect to t of this function. And if you can't do it, just consider yourself a failure. I'll tell you about my newest Chex Mix with Heinz 57 sauce. It's good. Heinz 57 sauce. I guess you could try A1. I haven't tried A1 yet, but what I want to try next is like barbecue. It's so nice to eat Chex Mix without pretzels. It just makes my day. It's kind of like killing rats or killing wasps. You just love to do it. Just love to make it without pretzels. So take the derivative. So this is going to be 2x dx dt using implicit differentiation plus 2y dy dt equals, I'll do this one for you, 0. There's your magic variable. That's what you want because you're given this. So now do it. I bet all of you that have never seen this before, I bet you can do it now because you're doing your algebra. You're solving for dy dt, and then you're going to plug and chug. And I bet you, even though, I bet you Mr. Wisenhunt can even do it. And he said he ain't seen this before. Because you're using your algebra.
90% of calculus is what?
Algebra.
Algebra. 15 minutes later, 4. I told you about my Calc 2 students that every problem I picked that semester, the answer to every problem was 4. Did I tell you about that? I had a Calc 2 class. It was about, met over there in 225, over on the other side. And Mr. Hart, he's on my Facebook page, he was in there and he just said, I'm just going to write 4 down. And I said, why? He said, have you not noticed that every problem you do comes out to be 4? I said, no, I hadn't noticed that. And just about every problem we had done. I mean, I didn't make the problems up. I mean, every problem I picked come out to be 4. So, y'all ever seen that movie, is it 23? Jim Carrey? Where everything comes out to be 23 and he goes crazy. He drives himself mad. All right, so I'm going to solve for dy dt. Well, I'm going to bring this negative 2x dx dt, bring it over. So that'll be 2y dy dt is equal to negative 2x dx dt. Divide by 2y, divide by 2y, the 2's cancel, and dy dt is equal to negative xy dy dx dt. I can't write. Now, what do we have? We have x. Let me just take my handy dandy highlighter. Green highlighter means we got it. We have x. We have dx dt. Then what else do we have? We need y. Can we get y? Yes, Hubert. How? That means I want y'all to answer. I want y'all to interact with me. Pythagorean theorem. Hopefully y'all are starting to see that 90% of this is all stuff that you know. So 10 squared minus 6 squared is equal to y squared. And square root of that takes that out. So y is equal to 100 minus 36, which is 64. 8. Plug that 8 in there now. So let's do the math. Negative 6 over 8 times 1. And what do you get? Negative what? 0.67, 6 over 8. Isn't that 2/3? What is it? 3 over 4, 0.75. Negative what? Negative 0.75 feet per second. Why is it negative, Hubert? Because it's going what? It's going down. No coffee, please. Now that's how you do a triangle problem. Now, what you need to do, if you're one of those people that have never seen this before, what you need to do is you need to figure out a way to put this in some kind of methodical, step-by-step procedure for you. When I learned it, I said, find a formula. After you draw a picture, find a formula, find out what you're given, and then work with that. I'd like to do another triangle just to kind of, let's see if I can find one. Hold on, I don't use this book very much, so just bear with me. Oh, there we go. I skipped the homework. I'm sorry. Okay. Okay, just like the book, I don't do that. So we'll look one up. Let's go with, I'm just gonna change this one. A ladder is 15 feet long, rests against the vertical wall, blah, 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 blah. Slides forward, which doesn't change anything really, toward the wall at a rate of 3 feet per second. How fast is the top of the ladder at 10 feet from the wall? Okay, I'm going to give you at least a couple of problems to do. So I just make one up because I didn't see a good one in the homework in the book. But I want you to start from scratch. Try not to use your notes. Now that I've shown you how to do it and what to depend on, really, and what to depend on, try to do it using what you know. Label everything. What is given, dy dx, or dx dt, sorry. X, y, if you want to go ahead and find y, go ahead and find y first. You're going to be using the Pythagorean theorem. All right, let me ask y'all something on Skype. When I freeze the, okay, I've frozen the picture on the, oh God, I can't even talk this morning. On the, what do you call this thing? Screen, forward. Do y'all see, do you still see the screen, or do you see me moving around on desktop?
See you moving around on desktop.
I don't know how to do that. Okay. Okay, well, I'll pull this up. Make sure you get this change right here. I'm going to get the roll here in a second after y'all write down the problem. A ladder, 15 feet long, rests against the vertical wall. At the bottom of the ladder slides toward the wall at a rate of 3 feet per second. How fast is the top of the ladder sliding up the wall should be up when the bottom of the ladder is 10 feet from the wall. Y'all got that copied down or got it changed on Skype? Okay, I guess everybody's got it. Okay. Ahmed is here with Skype. Anderson is here with Skype. Bradshaw is here with Skype. Edwards, okay. Grant is here with Skype. Huth. Khalil is here with Skype. Nabay is here. There's Mr. Huth. He's here. Nabay is here. Patel is here. Fear is here with Skype. Scobie is here. Sheik is here. Silver is here. Thompson is here with Skype, right?
Yeah.
Tucker is here with Skype. Hunt is here with Skype. Williams. Okay. All right. So first of all, again, we draw a triangle. Some frozen. And this is a ladder 15 feet. And we know that it's going to be 10 feet from the wall. And we also know that dx dt is equal to 3 feet per second. And this is y. And we want to find dy dt. Because we're pushing in at 3 feet per second, and this thing's going up, so we should have a positive answer. Now y, we can go ahead and figure y right now. 15 squared minus 10 squared is equal to y, and 225 minus 100 is equal to y. 225 minus 100 is 125. What's the square root of 125? I don't think it's going to come out. Say 144 is 12, 121, 11.2. So that's just algebra. Y is equal to 11.2. All right, so just knowing algebra and no calculus, you can at least find the side. Now, we've got all we need, but we don't have this. So that must be what we're solving for. So go over here and take your derivative in respect to t. So that would be 2x dx dt plus 2y dy dt is equal to whatever this comes out. It would have been 225 here. Really. I wish somebody could tell me how this thing changes from being an eraser. Maybe I could go to training. We got School of Technology. 225. And we're solving. So that's gonna be d what? dy dt is equal to negative 2x dx dt divided by 2y, and the 2's cancel, dy dt is equal to negative x y dx dt. Now, which way is this being pushed? So that means it's what? Negative. So now we've got everything we need. Dy dt. Mr. Hunt, have you had this before? Golly, you must have had a good math teacher. Dy dt is equal to what? Well, x is 10. Y is 11.2. And dy dt, dx dt is negative what? 3. So that's going to be negative, going to be positive 30 over 11.2. Calculator drill team. What is it? I'm sorry, what? 2.68 feet per second. So that means that if you're pushing at a rate of 3 feet per second, it's going to be going up 2.68 feet per second. Is that an alarm? Okay. Now, let me take this and transition it to the gravel. I hope I ain't got the wrong one. I'm just going to write this because I'm going to type it because I can't write good. You see how my writing is. Let's go with now you're going to see how bad my typing is. Gravel is being dumped by a conveyor at a rate of 20 at a rate of 20 cubic feet per minute. So what does that tell you about the problem? Volume. Good. It forms a conic pile whose base and height are equal. How fast is the height of the pile increasing oh, I spelled that right at 10 feet high when it's at 10 feet, when the height is at 10 feet. All right, draw a picture. Remember, the height and the diameter are the same. And I'll go ahead and give you the formula. Volume is equal to 1/3 pi r squared what? R squared h, yeah. Well, that sucked. Okay. Now, where does the secret lie? The secret to this problem is right there. And the secret to the problem is not in the calculus. The secret to the problem is in the algebra or the formula. What are you looking for? How fast is the height? So you're looking for the rate of the height, dh dt. Let's go over here. Gravel is being dumped by a conveyor. What is that? What is 20 cubic feet per minute? Good gracious, you on the ball. We did. And I can't find them. They're in my notebook somewhere. I've only found a couple, so I'm going by memory here. It forms a conic pile whose base and height are equal. Base is equal to height. How fast is the height of the pile increasing when the height is at 10 feet? So height is equal to 10 feet. So we've got dv dt, we've got b is equal to h, and we've got h is equal to t, but we're looking for dv dt. Because the last thing the question is asking. Oh, I'm sorry, yeah, dh dt, I'm sorry. dh dt. We're looking for dh, yeah, we can't find it, that volume right there. dh dt is what we're looking for. All right, so that's what we're given and what we're looking for. Now we go back to our formula and we say, okay, let's draw a picture. All right, there's basically what we got. And let's see, radius is this right here. But radius is the diameter divided by what? 2. Radius equals diameter divided by 2. Well, we know that the diameter is equal to what? H. Is equal to h. So I can put an h right here, and the radius is equal to h over 2. And we plug that in for what? R. V is equal to 1/3 pi h over 2 squared h. All right, simplify this. See, that's the secret to the pile problem. Is they're going to give you some kind of ratio, or ratio. They're going to give you some old ratio of H to R or H to D somehow. Get used to that, because when we get to the work problems, you're going to see this a lot. This is a good problem to kind of latch on to for the work problems. D is equal to pi over 3. I get tired of writing 1/3 pi. And H squared over what? 4? H over 1. So that H D is equal to H cubed times pi over what? 12. Now take the derivative of that. Now you pull the power of 12 out. You can pull that out and say V is equal to pi over 12 H cubed. Now take the derivative of that in respect to T. And see if you got what you need to plug and chug. If you don't, then that means you're pretty much a failure. Now let's take the derivative. So the derivative of V is dV dt is equal to pi over 12, and then that's going to be 3h squared dH dt. Now we go up to our handy dandy stuff that we have and stuff that we need, and or you can solve this, or you can plug and chug and solve. It doesn't matter. dV dt is 20 pi over 12. 3 and h is what? 10. And dH dt is sitting over here by itself. So it looks like to me it's going to be 20 divided by all that stuff on the right. Hold that together right. Yes, I did. So see what you come out with. I came out with 0.26. What did you come out with? 0.26 feet per second. All right. Yeah, pretty much feet per second or feet per minute. I don't know about the feet per minute since it's giving us per minute. 0.25, 0.26, yeah. So dH dt is equal to 0.26. So again, you need to take this problem and you need to put it in an organized, however you want to organize it. Some people might draw the picture first and then put the variable and then do the formula. Some people may do the formula first, write down what you need to find, which way you need to go with your steps and your methods. Okay? Now we're going to, I don't know, let's see. I think we're gonna call it day today because I wanna find my notebook. Because I don't wanna go over theta and I don't wanna go over I wanna go over those next. So what it looks like is this. It looks like we're gonna spend, what's today? Thursday. We're gonna spend Tuesday on rates and then Thursday and the next Tuesday on work. So we're talking about a test in, not this week, but next week. Not this week coming up, but next week. Okay, and it's going to be on these problems of rates, and it's going to be on work that we're going to go over, not next time we meet, but the next time we meet. Okay? Question. How about the Skype crew? Y'all got questions?
I'm good.
I'm going to put a few rates on the homework, and y'all can be working on them, but I'm not going to put a lot. I'm going to put just some triangle problems if I can find some, and I'm going to put some problems that are basic, and let y'all get warmed up on those, okay?
Will this video be put up on YouTube?
Say again?
Are you going to put this video up on YouTube?
No, I don't like you, so I'm not going to put it up. Yes, I put it up
I
every
appreciate
day.
that.
Okay?
Yep.
Any other questions? All right, y'all have a good day, and I'm cutting her off. See y'all later. Bye, Hubert. Bye, Skype people.
They live in their own world.